it will try to tell you a very good story. Okay, so let's try to select what is central tendency first. So central tendency is nothing but it is a way in which the group of data clusters around a central value. So this is what we call it as a central tendency. But the question is, why do we need this? Nice. Why do I need central tendency value? What are the
To
advantages that I'm going
compare.
to get? Excellent. One of the major advantages of central tendency values for comparison, isn't it, guys? So let me tell you. So there are two schools, school A and school B. Now you wanted to check like which particular school is faring good in the IQ levels, right, of 10th grade students. The moment you put some test, right, the more you will get some values. Because as an example, school A has 50 students in the 10th class, and you conducted some exam, and the average came to be 95. The school B, right, the same test has been conducted for the 10th grade students, right? There are again 50 students, right? When you took in a central tendency value, it came to be 65. Now will you be able to compare the results, guys? Same grade, same number of students, but different schools.
Yes.
Yes, right? So the reason the central tendency values are one of those very good measures which will help you for comparisons. Okay, but what else? Is it only for comparisons? Think through. It has nothing to do with respect to data science skills or statistical skills. If I'm getting a central value or central tendency value, how it is going to help me? One is for comparisons. What else? No, like keep on sharing your thoughts, right? As I said, it is all about sharing your thoughts. Don't worry about the accuracy or correctness of your answers. No one?
The most frequent occurring thing, for example, if a car race has been won on a specific type of car, with central tendency we can identify what is the most frequent used car type.
Okay. So in other words, let me rephrase a little. It is nothing but a representative value, isn't it, guys? Say as an example, in my school A, there are 50 students. Now, in this particular value of 95, the central tendency value of 95, is it not representing the entire 50 students? Yes or no?
Yes.
Right? So instead of having the 50 different values, some people might got 100, 98, 97, 93, 92, or whatever could be the values. But ultimately, I'm just trying to act, or I'm trying to just depend upon this final central tendency value as a representative value, isn't it? So there is the first and foremost usage of your central tendency value is it will act as a representation of the entire bunch of data elements that you're working on, right? And the second advantage, as our dear friend has said, it is all about for comparisons, right? So when you're trying to find one single value as a representation of the entire data values, are we going to condense the data or not? Is the data getting condensed in the representation form?
Yes.
Right? So definitely I don't require those 50 data points for the further analysis, right? I'm just depending upon this particular final value. So the reason there is data condensing is happening as part of the process, right? And finally, even though we talk about central tendency values as a descriptive statistical measures, but these same techniques is going to be helpful in further statistical analysis, right? The same values would be useful, some of those advanced and latest statistical analysis too. So don't think this is you're learning just a fundamental thing, but these fundamental topics are empowering some of the advanced or further statistical analysis. So this is the reason why people prefer central tendency values. And the moment you look at them as a mere number, it will not tell you a story, because data scientist has to be a very good storyteller. Because what you see is always numbers, but if you just project those numbers in front of the business teams and the business leaders, right, it will not tell you any story. So you have to tell a story based upon the problem statement, based upon the domain you're working on. Okay, guys, make sense? Very good. What is central tendency and why do you need a central tendency?
Yeah.
Excellent. Now let's try to talk about those three sub numerical measures that are available within central tendency. The first one is called as a mean, right, guys? I think we don't require any introduction. Guys, what do you mean by mean? How do you calculate the mean?
Sum of all the values divided by the count.
Simple. The sum of all values divided by the count of the values will give you the mean. So, but we are trying to talk about mean, right? So actually the mean is a word that should be used for population or sample.
Population.
As per the yesterday session, what we have learned?
For
Population.
population.
For population. But what do I call the central tendency value if I'm doing for sample?
Average.
Average. So, but when it comes to central tendency value of mean and averages, do you think the formula would change, guys? Will it change?
No.
No, right? So sum of all values divided by the count is the same whether you are trying to work on your sample of the data or else when you are working on the population of the data. Okay, but few of the numerical measures, the formula would change on the denominator side, but since you are living in a central tendency value, only that representation values, right, is going to change. So as you see here, in case of your average, it is been denoted as X bar. So there is an hat or there is a bar on top of the X that we are going to write. So this is a symbolic notation if you wanted to call it as an average. But the moment you try to talk about a mean, it is been represented by the Greek letter called mu. Guys, able to see this? The formula is not changing. Have you seen this? Sigma x by n. What do you mean by sigma? Sigma is nothing but summation of all the elements present in a particular frame. Okay, make sense? Are you clear about this? Any questions? Yes, are you clear?
Yes.
Okay, now guys, please be available. I'm just trying to write some numbers. I want you to calculate the mean of these numbers. If you are in front of Excel sheet or calculators, I need a quick reply. 60, 72, 61, 66, 63, 66, 59, 64, 71, and 68. So how many total numbers do I have? 3, 6, 9, and 10. So the total of 10 numbers. Now if I calculate the mean of it, what would be the value, guys? Anyone? Okay, 65. Okay, now observe this. Why am I trying to talk about this high school mathematics now? Guys, observe this. I'm going to copy paste the same data points now. Okay, I'm just trying to change one number. Now, Juhi, I am not expecting you to tell the numerical value here, but what are your observations? The same data points, what happened? Instead of trying to put one number to be of 68, I just updated to be 680. What do you think would happen now? What are your observations? What do you think would happen to the mean value?
It will be a larger number.
It would be a larger number. Okay. So what is the takeaway here? Guys, what is the takeaway? What is your understanding? Why did I show this example and what is an inference that you're able to make it now?
A small change can impact largely.
Do you think 68 to 680 is a small change?
I mean, the number 0. I mean, if it is an error.
Come on, Juhi. So this is not a small zero getting added, right? It is a 68. Say as an example, you're trying to calculate the age of a particular person. His age about 68. Now you made it a 680. You see, it's not a small change. Right? It's a huge change.
Yeah.
Right?
Mhm.
Getting 10x times more. 10x. Not I'm talking about percentages. It is 10 times more than the original number. Guys, what is an inference? Why did I talk about this example and what I'm trying to say here?
You can say mean is directly proportional to the data elements.
Okay. Okay, almost there. Can someone rephrase those statements?
Representation of the data.
No. So we say that mean is sensitive towards your outliers. Guys, it's not an outlier. The rest of the data points are hovering around 59 to 72. Suddenly, one of the value of 68 has got updated to 680. Is it an extreme value, an anomaly in the data or not? Yes or no?
Yes.
Yes. The moment your data set has, the moment your column, the moment your variable has extreme values or anomalies or outliers, can you make use of the mean as a standard value? Is it going to help you? Is it going to give you the good representation of the data because of just one black sheep?
No.
No. So the reason we say mean is sensitive towards such kind of an extreme value behaviors. Make sense? Yes or no? Can I make this statement or no?
Yes.
Yes. And the second important point is, can you calculate mean on the nominal type of data, guys? Can we? No, right? So the reason the data has to be numerical, which is very fundamental. Now let's try to move on to the second one. Right? So the first one is mean and the second one is median. Okay, let's try to understand what is median then. Guys, any idea? Anyone able to remember and recollect your childhood or high school mathematics? What do you mean by median?
Middle value in a sorted list.
Very, very important point is the suffix. It has to be sorted first, right? The moment people talk about median, they just jump onto the definition of saying it is the middlemost value. It is not about middlemost value. It is a middle score for a set of data that has to be arranged in the order of magnitude. It has to be sorted first. Once the data is sorted, then you can take the middlemost value for a set of data. Okay. Now let's try to select. Let me take an example and try to show you how can you calculate the median value. And again, guys, pay attention. My objective is not to show you the formula, these simple examples. My objective was to help you to understand this important point. Okay. Most of the data scientists, right? So they jump onto the machine learning algorithm without understanding the basic differences of when to use what. Okay. And my students should not fall in that particular place. Let me take a simple data point here. Okay. I'm just trying to take some random data points, the total of 11 elements that I'm going to provide here. And can someone help me? What is the first step? I have to first sort the data, isn't it, guys? So what do you mean by sorting?
From ascending to descending.
Right, from ascending to descending or descending to ascending. But the one of the most common way of trying to arrange any data is by default it happens in the chronological order of ascending. Okay, so I'm just trying to arrange the data. So what is the minimum value?
14.
14. And what is the maximum value?
92.
92. So it means I need to arrange these 11 data elements in the sorting order starting with 14 all the way to 92. So since there are the total number of elements is 11, we call them as even number or odd number.
Odd.
It is an odd number. So there are total of 11 elements. Since this is an odd number, what is the beauty of it? I can just pick the middlemost positional value. Guys, what is the middlemost position value in 11?
6.
Right? The sixth positional value is generally called as middlemost value, and which is nothing but my 56. 1, 2, 3, 4, 5, 6. So this is the middlemost number, which I can call it as median. Are you clear on this? Any questions?
Yeah.
How about others, guys? Is it only you in this session? No, right? How about others? Divya, Bindu?
Good. Yeah, it's clear.
So appreciate your responses, at least in the chat. I've been requesting this for all this while, but I don't see any replies in the chat. Guys, please do make a habit, either confirm over the voice or else confirm in the chat. It's up to you. Okay, now what I'm trying to do in this next example, on the same data set, what I've done, I just removed the 92 value. Okay, so what I will be left with? 10 or 11?
10.
There will be only 10 numbers. So I'm just trying to opt for the same ordering. Okay, right? If I have to sort the data, I can just make use of the same thing. Okay, without the value of 92. Okay, now if I have to talk about the median, now how many elements are there? There are only 10 elements, then it will become a even value. It means the middlemost positions would be 2, isn't it, guys? Yes or no?
Yes. Yes.
Right, but how do you deal with? Because I said if it is in the case of odd, there is only single positional value, so that I can just opt for that particular single value. But when you're dealing with the data which has even number of elements, then the middlemost position would be 2. Now how can I deal with this?
We can sum it up and divide it by 2.
Yeah, so what we do is we generally ask to take a simple average of those 2 positional values. It means my 55 plus 56 divided by 2 is nothing but a simple average of those 2 elements, which will help me to get the median value. Now the median value is 55.5 is my median value in this particular case. Okay guys, are we clear? How do we handle the median case in case of an odd number or in case of a even numbers?
Yes.
Clear?
Yes.
Excellent. Now let me put a little trick here. Okay. Example 3 on the same data set. On the same data set. I'm changing one number to something else. So there is a value called 89. I just update it to be 890. Now Bindu, what are your thoughts?
So if it is odd number, the median doesn't change.
Mm-hmm. You get to know, right? So I just copied the same data as part of the example 2, and I just updated one of the value to be of 890. Now what are your thoughts on the median value? What is your inference?
It doesn't change then.
Why? Because I updated the value, right? The data is no longer the same.
But we are taking the middle element, right? So
Mhm.
it is.
Okay, very good. So you can say always this with confidence. Guys, are you able to observe this? When I'm working with respect to the mean, the moment my data has some extreme value behavior, immediately the mean is getting impacted. But when it comes to median, even if it has some extreme value behavior, is my median getting updated or impacted by this? Guys, is it going to change? The total number of are still even. They're the same number of elements. I just sorted them in the chronological order. Since it is an extreme value, you just move towards the right, extreme right. So what happened? My values are still remaining the same. So what is the takeaway here? What is the takeaway?
Mean is not sensitive to outlier.
Simple. Mean is not sensitive towards your extreme values or outliers. So the reason people on your day-to-day jobs will prefer median if you suspect if your data has some extreme value behavior. So it means mean is not a good representation of your data if it has some extreme value behavior, and people prefer median over mean if data is either skewed out towards having some extreme value behavior. Are you clear about this, guys? This is very, very important, very fundamental, but very, very important. When do you choose what is should be very easy for all those data scientists. Clear? Any questions here? Okay, now the data has to be only numerical or only ordinal? Or it is, has to be numerical, ordinal, and nominal. What kind of a data that you can work on?
Only numerical.
Has to be numerical, and since ordinal data has also magnitude and sorting is available, right? If it is not throwing a very different ambiguous situations, you can definitely use the median values even for ordinal, because there is a magnitude and ranking possible on such kind of a data. Agree? Okay, now move to the third one, mode. Guys, what do you mean by mode? When can you call something as a mode? Able to remember anything?
I think it's most number of occurrence.
Yes, right. Even in the yesterday session where we are trying to talk about parent-teacher meeting, we talked about the mode, right? The most frequently happening element or item in a set is generally referred as the mode, right? So the most frequently happening element is generally called as a mode. Let's try to select what kind of an details that we will have. So I'm just trying to talk about the same data points, right? So whatever the data point that I have taken earlier as per the mean case, I'm just trying to make use of it. And if I have to call about the mode, guys, what is the mode? Which particular numbers are getting repeated here frequently, more than one?
55 and 56.
Oh, there are two? Are you sure?
Yeah.
Yes. So it means here in this particular set of 11 elements, there are two elements which are getting repeated twice. So the reason we call it as an by mode. Okay, because there are two elements which are getting most frequently repeated. So the reason we generally label them, we give such kind of an examples as by mode. Okay. Now for the same example, what I'm trying to do, I'm just trying to remove one of the 55 value because 55 is getting repeated twice on the same data set. I'm just trying to remove one number. Now what would be my mode?
56.
Only 56. Now you call it as uni mode. It means depending upon how many elements are getting repeated, right? We call them as bi mode, tri mode, penta mode, hexa mode, and etc. Okay, just a name. It does not tell you anything. It's just trying to tell you, okay, these are the total number of elements that are getting repeated in this particular set. What I'm trying to do now, I'm just trying to remove another number of 56. Guys, let me pick a person. Shashank, what is the mode of it?
There is no repeating number, sir. I think there is no mode.
Excellent, right? Don't say that it is like a penta mode or a desa mode. Okay, so guys, if a number to be called or to be eligible to be called as a mode, it has to be repeated at least twice, right? But here, each one of those numbers are unique. Is there any repetition on the numbers, guys? Is there any repetition?
No.
No. So the reason we call it as a no mode. Okay. So what is your takeaway here? Are you able to make any inferences out of these examples or the concept?
It is also not sensitive towards extreme values.
Very good. It is also not sensitive towards your extreme values because getting a repetition on the extreme value is very, very rare. Okay, because the moment we say anomaly, it is like a one of a case. Now you cannot expect a anomaly to be getting repeated many times, right? So this is when we say even your mode is not sensitive towards your outliers or extreme values, right? And at least with respect to relative to mean, yes, it is not at all sensitive to outliers or extreme values because the mean is the one which is getting impacted because you're going to make use of each and every value present in the set. So the reason the moment you have an outlier, your mean will get impacted very hugely. Okay, so the reason we can say that even your mode is not sensitive towards your outliers. And next thing, the data has to be, think a little, just don't answer fast. What should be the data?
It can be both numeric and categoric.
Very good. The data can be numerical or the data can be categorical too. Okay, are you clear about this, guys? It means the mode is a central tendency value which can be used for your numerical data, and if you ask me, it could be one of the best central tendency value for categorical data, right? Because the moment you're trying to talk about numerical values, here we are lucky that we don't get any decimal or floating point numbers. So the moment you're dealing the data with respect to floating point numbers, to getting a repetition to that kind of an decimal point value is very rare, right? But when you talk about categorical data, so definitely you could see a lot of repetitions in a particular scenario. So the reason you can claim your mode central tendency value can be one of the best measures for when you're dealing with the categorical data.
Good.
Okay, we'll get started. So what do we plan to learn today, right? So as part of the yesterday session, we just started our journey with respect to the central tendency, where we have gone through the mean, median, mode and try to evaluate our knowledge against the type of variable and type of scenarios. And we just started understanding the second measure, which is called as a measurement of your spread or dispersion. And even though we primarily learn the standard deviation and variances as part of this, but I just thought of sharing some of the other fundamental numerical measures which will try to help you to understand the spread of the data. Okay, guys, so the first one that we have learned is percentile, and the second one that we plan to learn is called quartiles. Right, as name says, guys, what does it mean? Quartiles. Does someone take a guess? Just a plain English meaning of quart. Anyone, guys? What do you mean by quartile? It's a normal English language that we always use for this. Any idea?
4.
Okay, so the moment we
Quarter.
talk about quarter, right, it is all about 4, right? So it means a quartile is nothing but we are planning to divide a sorted data set into 4 equal parts. Okay, so the moment you have 100 records with the number starting from 1 to 100, so if I have to divide this, I just need to sort this data and try to divide this entire data into 4 equal parts. So what does each part mean? So each part will try to represent 1/4 of the entire set that you are working on. Are you clear about this, guys? What is a quartile? A quartile is nothing but dividing a sorted data set into 4 equal parts. Is everyone clear about this? What is quartile?
Yes.
Very good. Now, as part of the yesterday's example, right? So if you remember, we have taken some 20 data points and we try to calculate the respective percentile values. Do you remember? So what are the different percentile values that we have calculated? Anyone? Are you able to remember what are the different percentile values that we have calculated yesterday?
Yes, 20 percentile, 50th percentile, and 75th percentile.
Excellent. So as part of percentiles concept, we have gone through the calculating the 25th, 50th, and the 75th. So by again going by the definition of percentile, what does it mean, guys? The percentile is nothing but a value below which a certain percentage of the data points will fall under. Agree? So as an example, if I say 75th percentile, what does it mean? How much percentage of data will lie beneath this particular value? 75 percentage. So the reason, the moment we talk about the quartiles, we are trying to name them as 4 different names. So the first one is called as an Q1. So what does it mean? The Q1 stands for first quartile. So since it is a first quartile, what is the equivalent percentile value here?
25.
It is all about 25th percentile, right? And since it is called as a 25th percentile, the other name that we can always use is called as lower quartile. So it's one and the same, whether you call it as an 25th percentile or whether you call it as an Q1, whether you call it as a first quartile or lower quartile, those are one and the same. So then comes your Q2. What does Q2 stands for in the same language?
Second quartile.
It is called as a second quartile. So since it is a second quartile, what is the equivalent percentile number?
50.
It is called as an 50th percentile. So in other language, if I have to name them, what should be the name? It is generally called as middle quartile. So other name for middle quartile is nothing but your median too, because as you know, it is a sorted data set and you are trying to talk about the middlemost piece. So definitely the second quartile, the Q2 is generally also be referred as a median value also. Okay. Now the third one is called Q3. So the Q3, as you know, so it would be called as an third quartile. Okay. And it is a 75th percentile. And what could be the name for this? We have a lower, we have a middle. What is left out?
Upper.
It is called as an upper quartile. And finally, when you have the topmost value, right, we generally name them as your fourth quartile. Okay, the fourth quartile is nothing but the maximum value or the 100th percentile value that you're going to play with. So this is how the percentile values that we have calculated yesterday is going to help us in trying to get the details. So do I need to calculate these values again, guys? If I'm going to refer to the same example that we have done yesterday, right? So do we need to do the calculations again or the values are readily available for us?
Readily available.
Yes, it is those are readily available. So the reason, as part of yesterday's calculation, I wanted to calculate those respective values where we have covered the percentile calculation values, and the same values could be reused when I'm trying to talk about the quartile. So for the same example that we discussed yesterday, the values would be something looking like the Q1 value. I don't know if you are able to remember, but the Q1 value is nothing but your 13.25, right? And the Q2 value is going to be 16, and the Q3 value is nothing but your 19.75. So this is how the quartile values could be given by making use of your percentile concepts. Make sense, guys? Are clear?
Yeah.
Yes.
Yeah.
So the moment we say quartiles, it is nothing but 4 parts. But as I said, right, it is not always that we need to divide the data into only 4 parts. It's up to you how many parts that you would like to do. So if you're trying to divide the data into n number of pieces, we generally name that particular concept as quantiles. The quart stands for 4 and the quant stands for n. Okay, so it means it's up to you whether you want to divide your entire data into 5 pieces, 4 pieces, or etc. It all depends upon you. But one of the most standard way try to understand the data distribution is to try to divide the data into 4 quarters and try to see how the data is varying among those values. Okay, clear about this?
Yeah.
Right, guys, is everyone clear about this? Appreciate your responses.
Yes.
Excellent. And again, right, so if I just try to look at these numbers, it is not going to tell you story, right? As I said, you need to always understand the things. So as an example, right, the Q1 stands for 25th percentile and the Q2 stands for 50th percent. So what does it mean? It means my 25% of the people are falling within a range of 2.75. Agree, guys? What is the difference between 16 and 13.25? It is 2.75. It means 25% of the people on the lower side are having just a difference of 2.75 maximum of. But when it comes to Q2, that is 50th to 75, you see what is the gap? It is 3.75. It means there is a huge variation. It means the same 25% of the data here on the upper side, right? They have been spread across a wide range of 3.75 as against 2.75. You got this? It means it is a little more densely populated towards the right side. Agree? The variation is huge on the right side. So because the percentage of data would be one and the same, but the spread is been a little dragged towards the right side. Agree?
Yeah.
Makes sense, guys? How about others? Are you able to understand the inference out of it? It's not about calculating or trying to understand quartile. If I try to talk in terms of values, how the 25% of the data from Q1 Q2 has been distributed and how the values have been getting distributed from Q2 to Q3. So this is what you need to understand. Appreciate everyone's response.
Yes.
Very good. Now move to the next one. What is range? Right, guys? Pretty normal language that we always say. What is the range? You go to any store, right? You go to anywhere. The moment you try to particularly talk about a product, you always look for a range, right? What do you mean by range?
Minimum and maximum.
Right? So the difference between or the distance between the lowest and highest values in a variable are generally called as the range. So it is going to tell you to what extent the minimum and values have a separate from each other. So the reason the range is nothing but a spread or the distance between the lowest and highest values of a variable. Okay, now let's try to take a simple example and try to say, as an example, right, I'm just trying to take few data points, say 20, 30, 40, 50, 60, 70, and all the way to 90. Now, what is the range of this value? What could be the formula when I say range? If I have to write it in a simple formula, what could be the formula for this?
Max value minus a minimum value.
The highest minus lowest value, which is nothing but the max minus minimum. Here the values would be 9. Clear, guys? Right? Pretty simple concept. I just thought of giving you a revision saying that even this could help you to get an idea about how data is spread across the minimum and the maximum values. So when we are trying to talk about the range, it is always considering the two values, that is about the minimum and the maximum. right? It's not going to provide you a greater details about some of the other ways. So the next metric or numerical measure that is going to help you to get better understanding on the spread or dispersion is IQR, right? So what does IQR stands for? IQR stands for your interquartile range, right? So when you're trying to talk about a normal range, it is been calculated making use of the maximum and minimum. But the moment we're trying to talk about the IQRs, it is being dependent on quartiles. So as you know, there are like Q1, Q2, Q3, and Q4, right? So definitely what I'm planning to do here is I'm interested in calculating the entire quartile range. It means I'm more interested about 50% of the data that is lying around my central tendency value. So guys, what are the two quarters which are lying around the center?
Q1 and Q2.
The Q1 is the middlemost value, right? I said around the center.
Q2 and Q3.
The Q2 would be the center, and Q1 and Q3 are the ones which are surrounding your central most value, right? The Q2 itself is a middlemost value, isn't it? When it says surrounding this, it means I just wanted to understand a certain amount of the percentage of the data towards the left of the median and a certain amount of the data towards right of the median. So the reason the respective quartiles that I need to consider is Q1 and Q3. Agree? Guys, make sense?
Yes.
Yes. So the reason when we talk about a normal range, it is the difference or a spread or the distance between max and minimum. But when we talk about interquartile range, I wanted to focus my energies in understanding the distribution of the data around the central tendency value called as a median. So the reason I can calculate the interquartile range as the distance between 25th percentile and 75th percentile. Are you clear on this, guys? How does an interquartile range can be calculated? It is the distance or the spread or the difference between your Q3 minus Q1. So this is how the formula could be easily be written as. So I will say IQR is equal to, it is nothing but the value of Q3 minus Q1. Okay, clear? Any questions?
Clear.
Yes. Now if I have to calculate the values, right? So let me just pick a person. Bindu?
Yes, Dinesh.
Okay, if you have to refer to the same example, since we got the values readily available, what would be the IQR value? If I have to use the IQR, what could be the IQR values?
19.75 minus 13.25.
Okay, so what would be the value?
6.5.
Yes, it would be 6.5. It means my 50% of the data is just lying within a difference of 6.5 value. You got this one, guys? So this is how if you try to visualize, right, how this quartiles interquartile range is trying to help you. It is going to divide your entire data, a sorted data into 4 pieces, and your entire quartile range is nothing but the range between 250 to 750. It means my 50% of the data is getting lied between 250 to 750 values here. Make sense? Clear? Guys, appreciate your responses.
Dhanush, I have a question.
Go ahead.
So the 500 is a mean or median here, right? What we have. If we are
It is
trained,
median.
yeah, sorry, median, my bad, sorry. Yeah, median there, right? But if you're trying to calculate the distance between 250 and 750 in general, in this kind of a bell curve, we use standard deviation, right, Dhanush? Just trying to understand a bit. Am I missing something there, or why are we talking about
No.
IQR? How we are applying it?
Okay, IQR is, as you know, it is a difference between 25th and 75th percentile. When you come, okay, let's go back to the percentile. So Shiva, what is a percentile mean from the definition or from your understanding? When I say 25th percentile, what does it indicate?
The percentage of candidates below 25 as such, or the population
so it
below
means
25.
25% of the data is lying below this particular value. Similarly, 75%. So the moment I take a difference of them, what am I going to get? Which particular section of audience I'm going to target?
The boundary around it.
50%. Yes, right? So 50%, it means my IQR is a very good measurement if you want to talk about the distribution of the data around your central tendency value. What is my central tendency value here? It is nothing but median. It means I'm
Right.
going to talk about distribution of 50% of my data around this particular median value. Got that point? So there is just related this the same value, right? This is my Q3 value. Below this, there are 75% of the data. This is my Q1 value. Below this, there are 25% of the data. But I'm interested in knowing how my 50% of the data is lying around my median value. So this is going to indicate me saying that this 50% of data are spread across my central tendency values. Okay, it's not going to talk about the entire horizon. It is only going to give you a view about 50% of the data around your central values or around the
Can you
median.
give any use case? There is probably missing from a real life use case. If you can just give a small use case.
Okay, so now to talk about this range example. So what is the use case that you're going to get? So when I say range, how does this going to help you?
Probably I can think about salary. I can think about salary range, how it might fall for a specific designation. I can
Excellent. Now relate the same example to the interquartile range, right? When you say salary, a fresher might earn as low as 2.4 lakh, and if you are trying to compare this to a outlier of CEO or someone, you might be learning into crores of money. Does it make a range? Does it make sense in those cases? A 2.5, like maybe a person might be earning 50 crores as a CEO in a very reputed organization, minus, right? And you're doing a 2.4 lakh. Does it give you a good spread of the data?
No.
No, right? You got the point. It means if you're trying to talk about the spread of the data by using the minimum and maximum values, it is not going to tell you the true story. But let me tell you, when you say interquartile range, so as an example, you talk about a median value. Is median get sensitive towards the outlier? Sure.
Yes.
Median, does it get sensitive towards
No.
outliers? No. So what happens in the median calculation? Will the CEO money comes into the picture here? Does it make an impact? No. So what happens? Your median value maybe comes around 8.5 lakh or maybe 10 lakh as an example. Okay. Now what I'm trying to talk about, now the moment I talk about interquartile, right? Maybe my 50% of the employees are spread around maybe 6.5 lakh to maybe 12.5 lakh, which is good, right? It means my 50% of the people are falling under a decent figure here. So that is how it is going to help you to gauge how the middlemost portion of the people or the data points are spread or what is the range of them.
Yep, that makes sense. Yep.
How about others, guys? Does it make sense? So always try to correlate this with respect to any data point or any variable or any business or domain you are working on. Only then you will be able to tell a story. Because this, when you try to implement in your RR Python, it is not going to shout out for us saying that, hey, this is what it means. It is just going to throw some numbers to us. It is up to us how do we relate, observe, find those inferences. Are you clear about this?
Yeah.
How about others? Excellent. Now move to the major things. So when someone is trying to talk about spread and what you call spread of the data or dispersion of the data, they actually talk in terms of variances and standard deviation. If you understand variance, you can understand standard deviation, as simple as it is. So what does a variance mean? Again, a plain English meaning of a word called variance. Guys, what does a variance mean? In general, I'm not talking in terms of mathematics or statistics. What does a word called variance mean? Okay, so as an example, right, maybe you visit multiple stores. Say that you are trying to purchase a particular product and you start visiting a lot of different stores. Now one person will say that, hey, this will cost around 50 rupees. When you go to the other store, they select 51. The other store said 52 and one said 50.5. Now do you call them as a huge variance? Is there any huge variation here? Guys, is it a huge variation? or deviations you find here? No. So in the other case, you're trying to buy another product which you generally cost to be 100. The moment you go to the next store, they say like it is 250 rupees. You go to the another store, they say like 375 rupees. No, you go to another store, they said like maybe it's 500 rupees. Now, is there any variation here?
Yes.
It's a small scale or a large scale?
Yeah, it's large scale.
It's large. So what does it mean? A variance is nothing but a measurement how far each element in the set is from its central tendency value. Here, when I say central tendency value, it is from the mean calculation. It means till this particular point of time, I'm trying to talk about the variance, right, with respect to a percentile, with respect to a certain quartiles, and with respect to difference with the quartiles. But I just wanted to get an understanding about each and every element present in the set, right? So as an example, if I have 5 data points, right, and I want to say what is the variance, what does it mean? Your variance here is going to measure how each element present in this particular set is from its mean value, because mean is a representative value, and the moment you're trying to talk about a representative value in the form of mean, I wanted to relate how each element present in this particular variable or present in this particular set is deviated from its central tendency value called as a mean. Guys, are you clear about this? What do you mean by variance? A variance is nothing but a measurement which is going to help us in understanding how far each element is from its mean. Are you clear?
Yeah.
Guys, please do acknowledge reply either through voice or through chat. That is important for me. Okay, so but how do you calculate, right? Instead of just trying to throw you a formula in front, right? I just wanted to talk about how does this particular value would look like. So what are the steps to calculate, right? The first thing, right, as you know, you need to have a mean, right? So the reason the first step would be we are going to be dependent upon a mean, right? But just this mean is a representative value, but my objective is to understand how far each element is from its mean. So when I say how far, what does it mean? Should I do an addition or a subtraction? Right?
Minus.
Minus. So definitely it means I need to subtract each element from its mean and try to take a square, because the square is important, because as you know, positives and negatives will get neutralized with respect to each other. So the reason taking a square will ensure that these positives and neutrals are getting converted into one common positive scale. Then it all depends upon the number of elements present in it, isn't it? Because some few variables will have just 5 points and few other sets might have hundreds of points. So the reason I need to take into count, right, what are the total number of elements present in a particular set. So the reason I'm going to take a simple average of these differences. So this is how by combining these 3 steps together, you'll be able to, right, visualize what is how does the mean values will look like. Okay, are you good about this, guys? So can someone take a guess? How does this variance might look like? Anyone? I just wrote the step by step, but if you try to club them together, you can take a guess like how does the variance might look like. Huh? Okay, so it is nothing but a simple summation of each individual item which I'm trying to represent as X minus the mean is generally be represented as mu. So it is nothing but X minus mu whole square divided by the N. Okay guys, clear about this? Are we good?
Yes.
Excellent. Now let's try to talk about some of the basic examples. Now guys, I'm going to pick a person. Now they have to help me in understanding how does this look like. Okay. Mohan, this is for you. I have a small set which has 5 elements in it, and each element is of a value 12. Can you please help me with the variance value?
Okay, so first should calculate the mean.
Mm-hmm.
So you want to add all those and divide by that?
It's up to you. This is a question given to you. It's up to you. How do you solve it?
Yep. Mean is 12.
Mm-hmm.
So that is X is an element. So is it going to be 0?
Obviously. So this is how I say, right? If you're able to understand something, the moment you see this, immediately it could get stuck. Like, say, these are like identical elements. The mean of an identical element would be the same, and if you're trying to do a difference of the element of each individual elements, right, from its mean, it would always be a 0. I need not even calculate, or I need not even think about the steps, isn't it, guys? Are you able to understand this?
Yeah.
If you're trying to work on identical elements, there is no meaning of trying to think about the variances. It would be obviously 0. Okay, let me add a little trick now. Okay, observe this, guys. Now, Juhi, talk about
There
the
would
variance.
be a slight increase.
A slight increase, right? Very good. Approximately. Guys, I'm not expecting you to substitute here at when I'm asking a question, it's all about what could be the change that you can witness on those values. Yes, there is a slight deviation which is of 0.1. Now observe these guys. Jilani, go ahead. What are your observations, or what do you think would happen now? What did I do? Jilani, are you there?
Yes, Dhanush.
Okay. What did I do, and what are your observations on this?
Yeah, very minute change.
Minute change. Okay. In the third example, what did I do first? What are the total number of elements?
6.
1,
5 elements.
3, 4, and 5 elements.
Yeah.
Now, what is the change that you could see in this example?
Fifth element was increased.
It is a small increase or a
Big increase. It's huge increase.
It means the moment in my set, if there are any extreme values. Now, what do you think about the variance? What do you think would be the value?
Near
Guys,
to 0.
Near to 0. Okay. Chilani, you need to always understand the basics. Okay. Let me help you again. See, if there is a identical data, you're going to get a value of 0. If there is a slight variation, right, the variance would also be very slight. If there is a huge variation, how can the variance would be very small? Able to understand this, Jilani? If there is a small deviation, of the number with respect to the other numbers, then the variance is going to capture the same spread, right? Okay, say that most of the elements are same, but just except one which is slightly increased with respect to the other elements. So the reason I got a value of just 0.1. Now, is it a very small difference or a very huge difference?
Huge.
When there is a huge difference, how can you expect the variance to be very small? Because variance is proportional to the changes in the data. Agree?
Yes.
So the variance would also be very large. And how large? You will be surprised. But what I'm trying to talk about, why did I give you these examples? Guys, what is our takeaway? Do you see any problems with them, or it's absolutely fine?
It's sensitive to extreme values.
Excellent. It is sensitive towards your extreme values or outliers. Guys, that's what I just wanted to talk. This is the same language that we have used in yesterday's session, and I'm going to use the same language here too. right? The reason I gave you these examples is sometimes you need not even think about the formulas. The moment you observe the data, if it is a handful of data points, definitely you can talk about the variances in the small, large, or very less. I'm not asking you to expect this to be told on your fingers, but you can definitely take a guess about how variance could be, or how large or how less the variance would be. Make sense, guys? Are you clear? The variance is sensitive towards your extreme values or outliers. Excellent. Now move to the second one. The other thing, I don't know how many will you be able to figure it out. Say as an example, right? I'm just trying to talk about meters, right? I'm just trying to talk about the variance in a meter. I'm just trying to measure maybe the size of a particular iron stick that I'm going to manufacture, and I'm just trying to talk about, is there any variances? Okay. So what do? You try to make use of this formula and you try to come up with the values. Now when you talk about those values, would be in the same units. Nice. Look at the formula. Would it be in the same units as part of my original variable?
Might
No.
not be.
Can you explain why and how? I'm talking about units. When I say units, what do you mean by unit, guys? Here in the
Meters,
measurement,
kilometers.
meters, inches, squares, right? Kgs, kilograms, or whatever it could be, right? It means when you look at the formula, it is squaring up the variables. When you do a square, what happens if I'm trying to measure in terms of inches? What would be variance value? Will it be in inches or square inches? It will become square inches. It means the variance values is not in the same units as the scores present in your data sets. Make sense, guys? Are clear? So these are a couple of problems that you are going to get with respect to variances. So the reason, right? What do? People generally prefer a trimmed down version of your variance, which is nothing but a standard deviation. Right? A one-liner definition. What is standard deviation? Nice. You should be able to. It's your little high school mathematics. Anyone able to?
Square root of variance.
Simple square root of variance. Whatever I've discussed about the variance is still the same, except that I would need to put a square root of it.